we'll be looking at the test we did the other day. We'll be going through question by question. I'll be adding some dialogue around the question as well. Any notes that you feel you don't have, maybe add them to your exercise book. Start with, let's look at this page. This is simple numeracy work, just addition and subtraction of negative numbers. So 3.2 plus minus 4.5. This is like that lesson we did where we had the hot air balloon and we added sandbags, or we added hot air. So let's draw a number line. This question says we're at 3.2 on the number line, and we add negative 4.5. So if we're adding 4 sandbags, we go down, we go to the left, so we're really subtracting 4.5. Subtracting 4 takes us around there, subtracting another 0.5 takes us there. So when you do 3.2 add minus 4.5, you end up at minus 1.3, so that should be your answer. Next question. So this question says we're at negative 6.4 and we take away 3.1. Okay, so if we're at negative 6.4, we're somewhere here. And if we take away 3.1, we move to the left. So moving 1, 2, 3 takes us to like negative 9.4, subtract another 0.1, and we end up here at negative 9.5. Okay, so question 3, minus 11 squared. Some people incorrectly thought this was minus 11 times 2. It's not minus 11 times 2. It's minus 11 times minus 11, minus 11 squared. So you should write this as minus 11 times minus 11. You should also know that a negative number times a negative number will end up giving us a positive answer. So the answer should be 121. Okay? So two negative numbers multiplied make a positive. You should know this. If you don't know this, you've either missed lessons, or you weren't paying attention, or you don't have complete notes. And if you got this question wrong, you should add some notes now to your book. Okay, we can think about why a negative number times a negative number ends up being positive by looking at the following situation. So what I'm going to do now is convince you that two negative numbers times together must be positive. Let's start from where we know. So we know 3 times 3 is 9, 3 times 2 we know is 6, 3 times 1 we know is 3. So what are we doing? Well, each time we're subtracting 3, we're just following this pattern. This means 3 times 0 is 0. If we keep subtracting 3, we get 3 times negative 1, that must be negative 3. Subtract 3 again, 3 times negative 2 is negative 6. Subtract 3 again, and we get 3 times negative 3 is negative 9. Okay, so now we know that a positive times a negative is negative, because 3 times minus 3 is negative 9. Okay, so let's start from there now. So we could write negative 3 times 3 equals negative 9. Okay, and then we could look at another question. We could look at negative 3 times 2. Well, this is negative 6. Okay, what do we do from there to there? Well, we added 3 this time. If we look at negative 3 times 1, we're going to add 3 again to get to negative 3. Negative 3 times 0, add 3 again to get to 0. Negative 3 times minus 1, well, we add 3 again to get to 3. Negative 3 times negative 2, we're going to get 6. And negative 3 times negative 3, that will give us 9. So this should convince you that a negative number times a negative number is positive. We've got negative 3 times negative 2 is positive 6, negative 3 times negative 3 is positive 9. So this is why negative 11 times negative 11 must be 121. Okay? So why is this true? Well, because maths doesn't break. All we did here was we followed the patterns. Okay, you can't break the patterns. Since maths doesn't break, it must be true that a negative number times a negative number is a positive number. Let's continue with the next question. So, given that fact that a negative number times a negative number is positive, negative 3 times negative 7 must be 21. Negative 0.5 times 8.4. Well, really, we're taking a half of 8.4, because 0.5 multiplied by something is the same as taking a half of it. A half of 8.4 is 4.2. But because we've got this negative sign here, we're doing a negative times a positive, so that gives us a negative answer, negative 4.2. Okay, in this question, number 5, we need to do 3.5 times something, times 4 is 14. Okay? But since it's negative 3.5, to make the answer positive 14, we must have a negative number there. So it must be negative 3.5 times negative 4 to give you positive 14. Lots of people made a mistake in this question. Okay, continuing with the next question. So, Nth term of the sequence is 80 minus 8n. Lots of people got confused with this question, probably because the nth term is written slightly differently to how we normally see it. Okay, remember, we'll go from scratch here, so we'll start talking about this from scratch. This, remember, is the sequence generator. It generates all the terms in our sequence. Okay, so we can look at the first term when n is 1. This will be 80 minus 8 times 1, because that's what the sequence generator says. That's what the nth term tells us to do. 80 minus 8 times 1. 80 minus 8 times 1 is 80 minus 8, which is 72. So the first term is 72. For n equals 2, we put 2 into our nth term. We get 80 minus 8 times 2, which is 80 minus 16, which is 64. For the third term, we put 3 into this nth term, so it's 80 minus 8 times 3, which is 80 minus 24, which is 56. Okay. If we have a look at this nth term, we can see that we're subtracting 8 each time. So we know it's like the negative 8 times table, or negative 8n. The negative 8 times table doesn't start with 72 though. The negative 8 times table starts with the negative 8. How do we get from negative 8 to 72? Well, we add 80. So this is like the negative 8 times table, but shifted by 80. Okay, so this nth term is minus 8n plus 80. Well, if we look at what the question said it was, the question said it was 80 minus 8n. These are the same things. Okay, so just because it's been written in a different order, don't get confused. It's still the negative 8 times table shifted by 80. They've just written it in a different order. Okay? So we're looking at the 8th term. That's the question. The 8th term. So we put 8 into the sequence generator. 80 minus 8 times 8. 80 minus 8 times 8 is 80 minus 64, which is 16. So that should have been your answer. Let's look at the next question then. Most people did this quite well. Most people realised that 7n minus 6 is like the 7 times table, but shifted down by 6. You might have written the 7 times table, which is 7, 14, 21, 28, 35. Okay, this is the 7n sequence. But because it's been shifted by 6, we take away 6 from each term. 7 take away 6 is 1. 14 take away 6 is 8. 21 take away 6 is 15. 28 take away 6 is 22. 35 take away 6 is 29. You might have said the first term must be 1 and just kept adding 7. That is also absolutely fine. Okay, so those are how to do those two questions. Let's move on. Most people did this question really well. They realised that it was adding 3 between each term. So it was linear, so it was like the 3 times table. The 3 times table goes 3, 6, 9. Our sequence doesn't start with a 3 though, it starts with a 12. So it's not the 3 times table, it's the 3 8 times table shifted by 9. So you should have written 3n plus 9 as your sequence, like the 3 times table, but shifted by 9. Let's look at the next question. This should be fairly straightforward. I'm surprised I'm even having to talk about this question because it's just multiplying and dividing by tens, hundreds, and thousands. Okay? So 0.04 times 100. Well, we're just going to be shifting the numbers up 2 places. Okay, so if we look at the numbers in a column, we could think about it as the units, the tenths, the hundredths, and the hundredths, the tens and the hundreds. If we write in 0.04, then multiplying by 100 shifts all our numbers to the left by, it shifts them 2 columns up because we're making them 100 times bigger. So if we shift them 2 places up, we would end up with the answer as being 4. Okay. Another way to think about this is to move the decimal place 2 places to the right. So 0.04, move the decimal place 2 places, and you end up with the answer 4. 0.7 divided by 10. Well, dividing by 10, we just move the decimal place to the left because we make the number 10 times smaller. So 0.7, move the decimal place, you get 0.07. Some people, which I quite liked, said, Mr. Cork doesn't like divide signs, so let's write 0.7 divided by 10 like this. They then said, well, we can multiply the top and bottom by 10 to give 7 over 100. This number is literally 7 hundredths. 7 hundredths is 0.07. What some people incorrectly did at this stage is instead of doing 7 over 100 is 7 hundredths, they did 100 divided by 7. Now that's not the question, it's 7 divided by 100. 7 divided by 100 is 0.07. Okay, 0.89, shift the decimal place 3 times, and you get 890. 6.9, move the decimal place 2 places to the left, you get 0.069. Okay. So that should have been fairly straightforward. No one really should have got this question wrong. If you did get this question wrong, then you need to really think about what dividing and multiplying by tens, hundreds, and thousands means. Okay, so finally, on this page, question 10, 29.4 subtract 13.8. This is fairly straightforward. It's just column subtraction. You should have got the answer 15.6. Okay, this question here, 4.5 times 8. You might have said, well, this is the same as 9 times 4, which is 36. You can times one thing by 2, divide the other thing by 2, and you get the same question. Or you might have just done 4.5 times 8 and got 36. Okay, so let's look at rounding. Most people did something correct here. Some people made a few mistakes. So to 1 decimal place, well, 108.06. We put a line after the first decimal place. We look at the second decimal place. It's a 6, so we round up. So it should be 108.1. Lots of people made a mistake with that question. Okay, 108.1 should be the answer. 0.947 to 1 significant figures. Some people who got this wrong incorrectly thought that 0 was significant. 0 in this question is not significant. The first significant figure happens after the first number that is not 0. So the first significant figure is 9. The second significant figure is 4. The third is 7. So we're rounding to 1 significant figure. Draw this dotted line after the first significant figure. 4 is less than 5, so we round down to 0.9. Okay, so that's to 1 significant figure. Part C, 383 to 1 significant figure. Again, the first significant figure, the second significant figure, the third significant figure. Let's go back a bit. So we put the dotted line in after the first significant figure. 8 is bigger than 5, so we round up to 400. Some people wrote the answer as 4. Now remember, you shouldn't change the size of the number. So 383 is closer to 400, much closer to 400 than it is 4. You can't change the size of the number. Also, if you wrote 380, there are clearly 2 significant figures in 380, not 1. Okay, so 400 is our first significant figure. Part D, 5.996 to 2 decimal places. Okay, so if we draw the dotted line after the second decimal place, I'll write the number again a bit bigger. Okay, so 6 we round up. So 9 rounds up to 10 effectively. We carry the 1. So then we have to add this 1. 9 plus 1 is 10 again. So carry the 1 again. And then 1 plus 5 gives you the 6. So it should be 6.00. You should really write 6.00 as your answer rather than 6, because 6.00 tells the examiner that you have rounded to 2 decimal places. Let's move on. Okay. This question is fairly straightforward. Again, I'm surprised I'm having to go through it. So the room is 3.7 by 2. So we have to work out the area of her room. So we do 3.7 times 2, which is just 7.4. Since we're working out the price per square meter, I'll go back a bit. Okay. Since we're working out the price per square meter, we're going to do 8.35 times 7.4. Okay, this is not necessarily easy to do, and when you're multiplying decimals together, I would recommend just doing 835 times 74, okay, and then working out what you've done to get that. So for 8.35 to 835, you've times by 100. 7.4 to 74, you've times by 10. This means that when I get the answer to 835 times 74, I'm going to divide it by 100 and divide it by 10, or just divide my answer by 1,000. Using column multiplication in the usual way, you should get the answer 61790. Do check you get this answer. If you've made a mistake somewhere, check your column multiplication matches with mine. So the answer to 835 times 74 is 61790. Since we really want to do 8.35 times 7.4, we had to divide this number by 1,000 to give £61.79. Okay, this should be the final answer. Another trick or something to note is if you look at the question, we had 3 decimal places in the question, right? So that means that we should have 3 decimal places in the answer. So we have, if we shift it by 1, 2, 3 places, I'll go back. If we shift it by 1, 2, 3 places, 1, 2, 3, then we get 61.79 as we should. So the number of decimal places in the question should be the number of decimal places in the answer. Okay? Let's move on. So, I won't go through question 14. If you got this wrong, have words with yourself. It's just subtracting and addition in columns. The only thing that someone might have made a mistake in is not realising that 6p is 0.06 pounds. Otherwise, it's fairly straightforward. Do correct this if you got it wrong and make sure you get the correct answer. You may have also misread the question and really want to change from the £50 note, not the total of the 4 goods. Okay. Estimate by rounding to one significant figure. So it did want you to round these two numbers to one significant figure. So 52 rounded to one significant figure is 50. 5.1 rounded to one significant figure is 5. 50 divided by 5 is 10. That should have been your answer. That wasn't very difficult. Most people just didn't know what to do when they were given that sort of question. Let's move on. Okay, so part A. Whenever we have multiplication questions like this, we're going to turn it into a multiplication that we know how to do and then change our answer accordingly. I'll show you what I mean. So we're going to change this 0.3 times 0.06 to be 3 times 6. 3 times 6 we know is 18. What do we do from 0.06 to 6? Well, we times by 100. What do we do from 0.3 to 3? Well, we times by 10. So this means we're going to divide our answer by 100 and then divide by 10, or just divide by 1,000. 3 times 6 is 18. Divided by 1,000, well, we shift it 3 places. So you should get an answer of 0.018. Okay, division. Now this question with division, we don't like the divide sign. Well, let's go back to the other question actually, part A. Note that because there are 3 decimal places in the question, there are 3 decimal places in the answer. Okay? This rule of thumb should generally always work. Okay? Part B, 0.8 divided by 0.02. Well, we've got a division question, we don't like the divide sign. Okay? So we do 0.8 over 0.02. What could we do here to make it nicer? Well, we don't like decimals when we're doing fractions, so we're going to times top and bottom by 100. Using equivalent fractions. This gives us 80 divided by 2, So we're using equivalent fractions here to make the division easier. So 80 divided by 2 we know is 40, so 40 is the answer. At this stage, when you get 80 over 2, you could use the bus stop method to do the division, or you could just simply leave your answer as a fraction in some situations. Let's do a different example where you have to do the bus stop method. So 14.2 divided by 0.03. We'll write it as a fraction, 14.2 over 0.03. We're going to times top and bottom by 100 to get rid of the decimals. Okay, so this gives a 1420 divided by over 3. We can at this stage do the division, remembering that it's 1420 divided by 3, so use the bus stop method, and find your answer that way. Okay, let's look at the final question here. So again, it's a timesing question, so we're going to turn it into multiplication that we like to do and then change our answer. So 400, we'll change that to a 4. 0.02, we'll change that to a 2. What do we do from 400 to 4? From 0.02 to 2, we times by 100. What do we do from 400 to 4? We divide it by 100. So we haven't actually done anything. So 400 times 0.02 is the same as 4 times 2, so the answer should be 8. Okay, that was all the questions. I hope some of those made sense. If any of them didn't make sense, make a note of them and come and see me about them, please. Anyway, thank you very much for watching.